line down the middle to kind of represent the equal sign, even though we know it's sort of facing the wrong direction. It's sort of vertical instead of horizontal. But if you're drawing this on your paper right now, and if you need Sharpies, I can bring more around, or highlighters, good solution. Now we've got the white side flipped up. And you know how approximately big it should be for the algebra tiles since you've been using them. And then we're going to check 614, but then you need 621 out. So make sure you have 614 and 621 out. These are the only homeworks due this Friday. Guys, I'm still fighting off like a sinus infection, which is one of those things that if you don't pick my nose and put it in your mouth, you're fine. I know that's gross, but like, so I can't speak up any louder than this. Like, I'm just putting out there. I got like my head's full of pressure. I can't speak up any louder than this. We got stuff we got to do today. My hope would be that we have time for homework at the end. Those two homeworks, 1-4 and 2-1, are the only ones getting collected Friday. I need to update stuff for Accelerated 7, but they're taking a test right now, so they're kind of at a pause moment. So, you guys remember when we went bowling back in the fall? Who? Okay, let's go ahead and say, give me a thumb scale of how good you are at bowling. I'm like pretty good. I'm like 75% probably. Okay. Nice. So, all right. So hold up. We've been asked to help the local bowling alley figure out their pricing plan. Now, if you've ever been bowling, who can tell me what you end up paying for when you go bowling? A lot. Well, okay, a lot is a general word, Gabe. You pay for shoes and you pay for games. So once we get done checking homework, we're going to talk about what should we charge for shoes, what should we charge for games, how can we make a decent pricing model. But everyone should have 614 out right now. 614, make sure your name's on it. Name. 614, Boone Sweet. 614, make sure your name is on it. You should probably work on this a little bit right now. Right on your homework with a Sharpie is a dangerous decision. Huh. Anyone recognize this problem?
That looks like the one from our mastery.
That's because it is the one from your mastery. Oh! Guys, that's the exact same problem as what was on our mastery.
It also says on your mastery that it's the same.
Any questions on 42? The stuff we can do to both sides now that we've had it on the homework and on the mastery, and we talked about it yesterday. Hopefully this feels okay. B, though, guys, if you look at B, we didn't have B on the mastery. We haven't talked a lot about this. Hey, if you're drawing on your paper, stop. Put the markers down. B sets up 4/5 of X is greater than 8. Guys, a few of you came and asked me, like, how do I deal with a fraction? Now, we could divide 8 by 4/5. But the better way, you know what we talked about, that R word? The reciprocal. Guys, look up here. I have a lot of people in half paying attention. I'm guaranteeing you a question like this is on your next mastery. I know it. Like, I already know what's on it. I edit every year. But I know that a problem like this is on your mastery. To destroy a fraction, to get it to turn into just 1, because we want 1x, you can always just flip the fraction over, so this 5/4, and multiply by that, because then we would get 20/20, and what's 20/20? 1. So we have to do that on the right side also. And guys, I would check your paper and redo this if you need to redo this. You multiply straight across the top of the fractions, straight across the bottom of the fractions. So my work right here shows we got 40/4, which is equal to 10. So x is greater than or equal to 10. There will be one like this on your next mastery, which are probably going to take another, at least like a mini mastery before the grade cutoff. All right, moving on since I've talked about both of those. In 43, we were testing. You were plugging in for x, and you were testing. Does it work or not? Is it true or not? Guys, make sure that we're working on this on our own time. So we shouldn't be doing our questions right now. Or at least not looking at the board. You could be like working on the back right now. You could be working on a different problem. Any questions on these? Testing it out. Only the first one fails. All other 3 results come out correct. Are we good? All right, moving on to 44. Guys, they tell you X, Y, and Z. You perform the operations they ask. Any questions on 44? Yes, part C turns into 0. (45) Perimeter comes out to be 4x plus 4. So what if x is 7? What if x was 5.5? Any questions? (46) Alden found the part 5D process. I don't know, short, medium, long. You could have said a lot of different things, but it sure looks like I'm going to have a short side, a longest side, because double the unknown number, and then like a medium side, right? Short, middle, and long. Could be a triangle, right? Alden could be talking about a triangle. So the long side is 2 times the short side. The middle side is 2 more than, right? The difference between 2 times and 2 more than. And then our pool problem. Any questions? All right. Jay, what's up, man? I don't know. Looks like about maybe 2/3 of us have our homework done, so okay. All right, moving on to bowling. So put 1-4 away. Please don't secretly be working on 6-1-4 during class. It's obvious. I'm kind of tall. I can see everything at the same time. Yeah, it's not really that much of a secret. All right, so I want you and your neighbor to start looking. Well, maybe you and Nate can team up since, I mean, you could even scooch up and work with Nate if you want. Start looking at this problem on 621. We're going to end up setting up an expression for each different pricing model. And, okay, so if we think about something that might happen multiple times. Hey, Lakin, you're doing way too much drawing. What might happen multiple times when we go bowling? Are you going to rent multiple pairs of shoes, or might you play multiple games? Multiple games. So keep that in your mind. Take like a minute or two, chat with your neighbor, try to figure out how could we set up expressions for these 2 situations. So we should all have pencils in our hand, because we're not here to doodle. That's my FCO class. How can we set up expressions for the 2 different plans? Well, it depends.
Think about that on your paper and throwing on Mr. Hudson's paper.
Highlighters might be real useful here since there's two different plans that we're comparing, we got Sandeep's current pricing plan charges $3 for shoes, $4 per game. The boss wants to change it to $11 for rent shoes, $2 per game. Layton, can you tell me how to set up? You can pick either green or blue. Could you tell me which? Like one of those that we could set up with an expression.
We can make a variable for the money for renting shoe and money for game.
So is it that we don't know the money? Or what is it that we don't know? So I'm going to say S equals for Sandeep's plan. Sandeep's current plan, which of those things would only happen once? The shoes or the game? Do we know what the shoes are?
Shoes. You can change it. Oh, there.
No, do we know, like, can I walk in and say, I'm only going to give you $1 to rent your shoes?
No, but the boss can change it.
Well, but if we're looking at Sandeep's current plan, and if you want to pass, we can pass, because I know you weren't maybe spending as much time on this as you should have. $3 to rent shoes, $4 per game. We're trying to set that up in an expression. You think you can help me, or should I pass for now? $3 plus what? Because we're not just going to rent shoes unless we just want to walk around looking stylish. Well, how much is it per game?
Wait, why are we getting E for S? Should we make X?
So S is representing Sandeep's current plan. This is, it doesn't even really need to be there. We could just erase that and say whatever. Currently it's $3 and $4 to play a game. But are you only going to play one game? There we go. So make sure that's written on your page for Sandeep's current plan. Moss, what about what I have highlighted in blue for what his boss is thinking about? I'm going to say B for the boss's plan, but we don't even really need, like, we're just setting up something.
So, it's 11 times, no, it's 11 plus 2.
Yeah, 11 plus 2 times X, because the boss is saying, let's charge 11 for shoes and $2 per game.
I mean, I feel like that would be smarter because you only have to buy one pair of shoes and then they would be more expensive. So, yeah.
So who thinks Sandeep's current pricing plan is what we should stick with? Ooh, it depends, Gabe. Who thinks we should switch to the boss's plan? So a bunch of you have no opinion at all?
Apparently, it depends on how many games you want to play.
Depends on how many games we're going to play. So let's say, what if, let's figure out that number of when these plans are equal to each other. So let's, oh, come on. My smart word's not going to work together with me. Let's set these equal and try to solve, which is exactly what's on your paper, guys. This 3 plus 4x and this 11 plus 2x, build it. Like on your equation mat, I should have probably... No, I'm just going to build it up here, actually. I'll build it onto the camera. On your equation mat, let's build it. You could have highlighted these things. So again, you could be using your expression comparison mat. Now we just have to tell ourselves the left is equal. I'm asking you a very minimal thing. What's that? What?
So, what were the questions again? I'm sorry. So we're just actually building this. Oh, yeah. So you got it pretty much.
If you are missing some ones, I got some extra stuff up here. If you don't have enough tiles.
Keegan's got it started for you. I'm doing the other I know. Why don't we $3? Yes. Yes. We're not doing this. So start with the first one. If it costs $3 for each game, it's $7. Then if it's $4 for each game,
If we set this up and start doing those legal moves we're allowed, June, can you tell me one thing that I could start by doing either to both sides or if there's zeros to cancel out on one side? Like, I don't know that we have any zeros because we don't have any negatives. We can't do anything?
You can do stuff, but you can take 2 away from each side.
Ah, to what?
2 extra.
Yeah, so since we can take these 2 X's off of the right side, we can take these 2 X's off of the left side because we can do the same anything to both sides. Turn to your neighbor and say what we're going to do next to both sides. That's just how it works.
What?
So then, Moss, what else could we do to both sides? Because I could take 3 ones off the left side, I could take 3 ones off the right side. Ooh, I don't know if I can't do anything. Misk? Is there any? I got 2 X's over here. I got 8 over here, but actually I might switch my 8. I should probably put these to just be 1s, so I should replace my 5 tile with some individuals. I got 2x equals 8.
Well, 2x, can you like make 2x, x, and 8 before? I don't know.
Well, can I split my left side in 2?
Yeah.
If I do that, what do I have to do to the right side? Split it in 2. So guys, on your paper, 49. Hey guys, 49. Lakin. 49 is this problem. When we get to 2x equals 8, guys, you don't have to write all the other work. When we get to 2x equals 8, what we're going to show on our paper is we can divide by 2. Sorry, my brain's getting ahead of myself. We can divide by 2 and be able to get to x equals 4. Try the same tech. So what is that telling us? If x is equal to 4, that made the left side equal to the right side. Anyone gotten it? What were we solving for with x? What was our situation from the start? Which plan is better? So this is, if x is 4, that means 4 games makes the plans equal. At 4 games, these plans will be equal. Because this mat represents what we just said, and we solved it out, x equals 4. Miss. Well, so this is only at 4 games will these two plans be equal. Guys, I got something really cool to show you. Look up at the screen. You know Desmos for the activities that we go do in Desmos. But watch what else Desmos can do. What was our first pricing plan? 3 plus 4x, right? And this will show us the graphed line. Guys, I should see eyes on the board and like pencils should not be moving right now because we're looking at this together. What was our second pricing plan? 11 plus 2 times x, right? This graph is showing me the 2 different pricing plans, and where the lines cross is at x equals 4. So then, and guys, you can use Desmos for all kinds of crazy stuff. I just want to keep peppering in like how you can use Desmos. So then if we bowl 7 games, figure out with your partner which plan is cheaper if you're going to bowl 7 games. Which plan is cheaper? I need to go back to my smart board. What's up? Where? In the bathroom? Man, I'm going to Clorox wipe that. I don't really want that on my desk right now, but thank you. I appreciate you bringing it back. I don't know if it's stuck to somebody's shoe or what. It's an algebra tile.
Oh. I guess it must have been if that person found it in the bathroom. Gross.
So you guys think 7 games? Part B is 7 games? At 7 games? Nope. We just figured out they're equal at 4 games. So we have expressions. Come on. We're getting these out of here. We have expressions written down. We need these 2 expressions written down. Grab your pencils. We just found out they're equal at 4. Your math is incorrect. X is our unknown amount of games. Right? We need to write down expressions for these 2 games. So $3 restrictions and $4 for games. We should have written down 3 plus 4x. So go ahead and write that down either here or down here or somewhere. Then we have $11 restrictions. So that only happened once. $2 per game. So we need to write down the expression for that, which I've got up there. It's 11 plus an extra 2x. We set these expressions. Now you're on this. And we did some stuff. But if we get down to the point of x plus 2 plus 3 equals 8, cut to 8 plus 7, and you have 11. So why do you say if x is 7, bring it back. Bring it back. These were our expressions for Sandeep's current plan and the boss's plan. So we're going to say these are probably not going to be equal if it's 7 games because we just figured out they're equal at 4 games. Boss?
Okay, so what I did I did 4 times 7.
Yeah, because now x is going to be 7.
Yeah, and then I did that and then added 3 and it was 31.
Yeah, 28 plus 3 more, 31.
And then for the other one, I did 7 times 2.
Yeah, 14.
And then I added it to 11 and I got it.
So if we play 7 games, which plan is cheaper? Actually, the boss's plan is cheaper. Yeah, if we play 7 games, the boss's plan is cheaper. Also, on your paper, try 50. This one's also on your paper. It's the middle. Hey, they're not numbered. Numbering was like messing with me with trying to print this. 50's right here. Set it up with tiles if you want. Draw arrows for what we're allowed to do. I'm going to knock over all my algebra tiles. Ooh, now we do it positive.
I divided it in half.
That's dangerous. You don't have They're somewhere, I'm sure. I just lose track of
They
it.
started stealing
Oh.
cans. They were coming.
I'm done. Yep. Oh.
Well, no, I know.
Yeah.
That one, I'm like, what? Addie, what are you doing?
Jana. All right, bring it back. Bring it back now, y'all. 2 hops this time. All right, Jana. How could I start here?
I did,
Hey, Jana's talking now. You're not.
you, add, not add, but like, the negative and positive, ones, and then the negative ones.
So positive, negative pairs. We can show that on our algebra mat. Guys, we're all going to need to be writing a couple things down because we need to practice those algebra skills. So let's cross these out. Let's cross these out. But now that we've done our zeros, let's write down what we still have. What do we still have on the left side? 3x plus 1. So let's write down 3x and an extra 1. Equal to, what do we still have on the right side? What? On the right side?
Oh.
And x plus 5. And x
I'm asking you a question.
Nah, not or. We've been told these are equal. Right? We've been told they're equal. So Destiny, what could I do now? And we can scooch back to just looking at my mat, or we can look right here. What can I do now?
Yes. Does that make sense now? Yeah. Okay. No, I know.
Hey, so Destiny, say it again. Take out one x from both sides. Hey guys, I'm not going to talk over you. So if you don't hear me and you don't do this, it's going to be tough when you have a quiz next, but that's fine because it's going to count for this Discovery Day. And if you'd like to be here on this Discovery Day, that's up to you. But the algebra that we're going to write on both sides is minus an x. This is a trap door. (3x minus x). Do we just now have 3? No. This 3x minus x is minus 1x. So what do I have left on my left side? Well, I can also look at my mat. What do I have left? 2 x's. So we got 2x plus 1 equal to 5. Go ahead and try to finish that out with you and your partner.
Well, no, because x and 1 are different.
So you're not following the process that we're doing together, and you're not making algebra.
If you're divided by
If you're going to fight on this, it's up to you, but you're not going to know what you're doing. 7 minutes.
Yeah, I mean, it still works. Yeah, that just is kind of a way to do it. It still works. Yeah, I know. I like there. Yeah, I do. No, wait. Oh, no. Well, we're not done.
You know, the rest of the day will be great.
So we have to get the x by itself. So once you get to this point, like you've already done enough as you can, right? Here on the map. So once you get to that point, you gotta see how we get here when we divide it by 2.
You want to get?
But see how you divide it by 2.
I might use some different.
Oh my god. My friend Joe.
Dang it!
Lily, what can I do now? Told Lakin he can have a break for a couple minutes. He promised the rest of the day will be better. Lily, -1 from both sides. So now we would get 2 times x, right? You don't have to write the times, but you can. Equals 4. Guys, I maybe didn't give you quite enough room. Nate, what could we do now if we have 2 times x equals 4? On both sides, we could... How do we get rid of 2 times? What's the opposite of multiplication? Division. So we're going to divide by 2, and now I'm writing all over the rest of the paper. And we get x equals 2. Let's go. We need to practice the algebra. We need to practice the algebra, and I'm going to make an executive decision to skip 51 right now and look at 54, because I got some people that aren't doing the algebra, and I want to make sure that we understand the difference between this with the mat and this without the mat. So without the mat, we're not getting out tiles. we need to write down what exists on these two sides. What's up? I have no idea until we go to solve it. So what do we have on the left? Can you help me set up the equation? Because we got to start with the beginning, not the answer. We'll shoot back to you for the answer then. Moss, what do we have?
Okay, so on side A, we have 3x plus 3.
3x plus 3.
The other side is 12. Yeah, this is plus 12.
Okay, so then what could I do to both sides, Alex?
Both sides, could you divide?
I mean, we could, but we don't really want to yet, because if so, I'm still going to have these extra ones over here. We probably want to get these extra ones out of here first. Do you want to try again, or do you want to pass? Lindy?
You could take off, you could take off the amount, like, you can't really see.
It's on your paper.
Oh.
This is part of your homework, guys.
You could take off 3 on both sides.
Hey, guys, we're doing your first homework problem. Write the original equation represented. Check. If you did this, you got it. So then, simplify the maths as much as possible. We can take these 3 away and take whatever 3 you want away, and we write minus 3 on both sides to show the algebra. Then we get left with 3 times x equals, what's 12 minus 3? 9. And now, how do we undo 3 times? Anybody? Divide by 3. And x will equal? There we go, Lakin got it.
Or you could just ask yourself, what times 3?
Well, because they still gave us the picture. Hey guys, I'm going to relate this in a way that may or may not land. And this is why I keep trying different things. You'll see me after class. This is like when you switch from reading picture books as a child, and you're like, oh, look, the cow goes moo, the pig, and you're looking at the animals. Now we're trying to transition over into algebra, which is what you're going to be practicing all through high school, where we won't have the picture. We won't have the tiles. You won't have stuff to move around. You just got to do all the math on the paper. This is what we need to be learning now, not this. This is what we're switching to now that we're in chapter 6. What's up?
Can we just learn how to change the equation into a board thing?
Not really, because once we get into complex algebra, there's decimals used, and yeah, it'd be way too complicated to draw the picture. That's all the time I got. Have a great day, guys.
That's really scary. Because the last time I called out, we all just became a desperate house. Are you sure you don't want to do it? Try to have a good day.
Ivan, I need your folder. I need to chat with you.
I double checked. You did not want to go on the break.
Yeah, I asked him.